In this video, we're going to look at another example of special right triangles, specifically a 45, 45, 90, and using the ratio of the sides to solve for some missing stuff. All right, so let's take a look and see what we have here. We're going to look at part F. I see I have a right triangle, and one of the angles is 45, so the other angle is 45. Remember, when you're working with right triangles, you need to figure out what kind of triangle it is. If it's a 45, 45, 90, or if it's a 30, 60, 90, then you can use your special ratios. If it's not, you're going to have to use another method to solve it, like Pythagorean theorem, or when we get to it, trigonometric ratios. But for this one, we have a 45, 45, 90, and we're just trying to find the two legs. So I'm going to label my sides. This is going to 1 to 1 to root 2. And once I find x or y, I'm going to know the other one because these are the two legs. So let's go ahead and set up a ratio. I'm going to do the black over the red for this. So I'm going to do x over 1. I could have started with y if I wanted to. And then black over red here is 5 over root 2. Alright, so let's cross multiply. I get x root 2 is equal to 1 times 5. This is typically how we'll write this when I have a variable with a square root, so that we don't confuse the x being underneath the square root. Just wanted to point that out. Alright, so I have x root 2 is equal to 5. We'll divide both sides by root 2. So these cancel out, and I get x is equal to 5 over root 2. And it is not simplest form to leave a radical in the denominator, so we're going to simplify that. So if you recall from previous videos, we reviewed this concept. In order to simplify this, we're going to multiply by a form of 1. So whatever this radical is, I'm going to put that in the numerator of a fraction and also in the denominator of a fraction. So really this whole thing here is really just 1. It's just an interesting form of 1. So then I'll multiply straight across, so I get 5 times root 2 in the numerator, and then root 2 times root 2, which is root 4, showing all the steps here. And then I get 5 root 2 over the square root of 4. The reason we did this is because 4 is a perfect square number, so the square root of 4 is 2. So I get x is 5 root 2 over 2. Again, x and y are the legs of this right isosceles triangle, so they have to be congruent. So y also has to be 5 root 2 over 2. All right, make sure you get your questions answered. It's always a good idea to rewatch the videos, and we'll see you next time.